Okay? So, oh, wait. So, we have the implications denoted by this symbol, and this is read as if P, then Q. Now, just to recall, the proposition P, this one is called as the hypothesis or antecedent, and the proposition Q is called as the conclusion or the consequence. Okay, so that's the part of the if then statement, implication statement. Now, from if P then Q, we're going to reverse the two, and we call this as the converse. So if Q then P is now the converse of if P then Q statement. And negating both P and Q, starting with P as the hypothesis, and we have if negation of P, then negation of Q, we call this as the inverse of if P then Q. And lastly, we reverse the two, and then we get the negation. Negation of Q, if negation of Q, then negation of P, this is called as the contrapositive of if P then Q. Okay. Now, let's consider the examples here. Statement P, a triangle is a polygon. The sum of the interior angles of a triangle is 360. As regards to their truth value, we know that a triangle is a polygon. It's actually a three-sided polygon. So this is true. And the sum of the interior angles of a triangle is 180, not 360. So this makes the statement false. Okay? So if we're going to combine this using the implication connective, so we have if P then Q, we have if a triangle is a polygon, then the sum of the interior angles of a triangle is 360. And we come up with TF, so this would be a false statement. Now, again, in the EP then Q statement, if the premise or the hypothesis is true and the conclusion is false, then the truth value of EP then Q is F. Otherwise, everything will be true. Like, if this is true, this is true, true. Now, whether this P, if P is false, whether Q is true or false, it will then be a true statement. So that's from the truth table that I have discussed last time. So as far as if P then Q is concerned, we'll come up with false as the truth value for this one. Okay. Now, how about its converse? So we have if Q then P. If the sum of the interior angles of a triangle is 360, then a triangle is a polygon. So take note that the order of P and Q here was reversed, such that Q becomes the hypothesis and P becomes the conclusion. And this is FT, right? So this is F, this is T, this is true, this is false, right? So if Q then P is FT, so this will be a true statement. Okay? Now, this is the inverse. If negation of P, then negation of Q. If a triangle, so take note that negation of P will come up with a false statement because originally P is a true statement. Also, negation of Q is a true statement because originally Q is a false statement. So going back here, if negation of P then negation of Q, if a triangle is not a polygon, then the sum of the interior angles of a triangle is not 360. Or we kept on making use of the phrase, it is not the case that. So other way of expressing the negation is making use of the word not. Now, this is negation of P, negation of Q. So we have FT. So FT is true, right? From the truth table of the implication. So this is true. And lastly, if negation of Q, then negation of P, this is the contrapositive now. Okay. So this is the converse. Converse of if P then Q. And this is the inverse of if P then Q. And this is the contrapositive class. Contrapositive of if P then Q. Okay. Now, we're going to consider negation of Q as the hypothesis, while
I can't hear you, ma'am.
okay, sorry. I was accidentally muted. Okay. So if the sum of the interior angles of a triangle is not 360, so that's the negation of Q. So in here, negation of Q is the hypothesis, while then a triangle is not a polygon, negation of P as the conclusion. So we have TF here, and TF is a false statement. So comparing the truth values of the four statements, like this is true, um false pala, no? Yung kanina, it's a false statement. If P then Q is a false statement, right? So this is false. Now, if Q then P is a true statement, as well as negation of P then negation of Q is a true statement. And then the other one is negation of, ayaw niya na. Negation of Q, then negation of P is a false statement. So meaning, um, if then statement is logically equivalent to its contrapositive. Why? Because they have the same truth value. Now, um, the converse and inverse of an if then statement are logically equivalent because they got the same truth value. Okay? So we have the if then statement, we have the converse of the if then, inverse, and contrapositive. And you see how each statement was constructed. Okay? And the relationship of each as regards to their truth value. Okay, let's have another set of examples. So we have P, a chord is a diameter, and then radii of the same circle are congruent. Anyone who can tell what's the truth value for statement P? A chord is a diameter. Now, a chord, the endpoints of a chord is located on the circle. So, for example, if this is a circle, and then we have this line segment, this one. So, this is an example of chord, this line. When we say diameter, let's say this is a perfect circle, and this is the center of the circle. A diameter passes through the center of the circle, and the endpoints are on the circle as well. Okay? So this is diameter. And the diameter, divides the circle into two equal parts. So we could say that statement P is a false statement because a chord is not a diameter. A diameter is a chord. Okay, so from the definition of a chord, the endpoints of a chord are located on the on the circle. Okay, so these are the endpoints, right? So the endpoints are on the circle. The diameter as well, the endpoints of the diameter are on the circle also. The difference is that this chord will either pass through the center or will not pass through the center. So meaning a diameter is the longest chord. So a diameter is a chord, but not necessarily a chord is a diameter. So this is a false statement. Now radii of the same circle are congruent. So this is the plural form of radius. Okay? So a radius class, the endpoints of a radius is the center of the circle and any point on the circle. So for example, if you have this point, okay, so this is one radius of the circle. Okay. Now, if we have another point here, and then we connect this with the center, so this is another radius of the circle. Now, radii of the same circle are congruent. Why? Because if you're going to work on the distance on any point to the center, it's equidistant. So, as long as the radius belong to the same circle or radii belong to the same circle, they are congruent. So, it's a true statement. Okay, so how do we write this in implication? Can you dictate the answer here? Anyone? Raise your hand virtually if you want to answer. You'll just connect the two propositions using the connective implication. Sige, ako na lang. If a chord is a diameter, then radii of the same circle are congruent. And what's the truth value for this? So this is FT. So this is true. Okay? So how about the converse of that statement? So we have if radii of the same circle are congruent, comma, then a chord is a diameter. And the truth value here is F, false, because QP is TF. Okay, so it should be false. So we have if you then P as a false statement. So this is false. Okay, next. Okay, nawala yung negation. There should be negation here. Negation of if negation of P, then negation of Q. So that's the inverse of if P then Q. Okay. Sumabay-sabay na sila. So this is if a chord is not a diameter, comma, then radii of the same the same circle are not congruent. Negation, no? So here, take note that P, negation of P is true, while negation of Q is false. Okay? So this is, if negation of P, then negation of Q. So we have TF. So this will now be a false statement. And lastly, the contrapositive version of if P then Q. So we have if negation of Q, then negation of P. So we have if radii of the same circle are not congruent, then a chord is not a diameter. So this is FT, right? So the truth value is true. Again, as what I was saying, guys, implication if P then Q is logically equivalent to its contrapositive. Negation, if negation of Q, then negation of P. Likewise, converse and inverse are logically equivalent also because they've got the same truth value. Question on if P then Q, the converse, the inverse, the contrapositive. Do you have question, guys? Okay, so I'll proceed. Okay, so when we say mathematical reasoning, this is the ability of a person to analyze problem situations and construct logical arguments. And basically, we have two types of reasoning. For instance, inductive reasoning is the process of making general conclusions based on specific examples. So here we begin with a specific example and then we come up with our general conclusion. On the other hand, when we say deductive reasoning, this is the process of making specific conclusions based on the general principles. So you will start your argument with a generalization. You start first by creating your generalization and then come up with your specific example. Okay? Now we're going to identify as to each statement is inductive or deductive. Okay. Number one, every crow I have ever seen is black. Therefore, all crows are black. So we begin here with a specific example and then we come up with a generalization. So this is inductive. All men are mortal. I am a man, therefore I am mortal. What's this class? Is this inductive or deductive? Anyone?
Miss, I'm still confused.
Mm-hmm.
I'm still confused with inductive and deductive.
When you start with a specific example, that's inductive. When you begin with a generalization, that's deductive. So in number one, we started with a specific example and then we come up with our conclusion generalizing. No, we generalize in the conclusion. So that's inductive. In number two, we have a generalization. We started with our generalization that all men are mortal. With that, there was specific example that I am a man, so therefore I am mortal. So here, in the second example, we begin with generalization. So
So it's
you just
deductive po.
I'm sorry.
Number two is deductive po.
Correct. Sino yung
Mm.
nagsasalita?
Nika po, Nika.
Okay. So that's deductive. Correct. Oh, here. A square is a quadrilateral. We cited an example, which is a square. A trapezoid is a quadrilateral. Therefore, all four-sided polygons are quadrilaterals. So this is what? So this is deductive for number 2. Inductive. So how about number 3, guys?
Inductive po.
Correct. So it's inductive. Number 4. SOFA students are creative. I am a SOFA student. Therefore, I am creative. This is referring to all SOFA students, right? So we started with a generalization. So that's deductive. My math teacher is strict. My mom's math teacher is strict. Therefore, all math teachers are strict. What's number 5?
Inductive.
Inductive.
Correct. PB is a shelter dog. She is happy. All shelter dogs are happy.
Inductive.
Inductive. My mother is Irish. She has blonde hair. Therefore, everyone from Ireland has blonde hair.
Inductive.
Inductive. So, for you not to get confused, you look at the first statement, how it was how it started. If it started with a generalization, then it's deductive. If it started with specific examples, then it's inductive. Okay? We are done.